Assalamualaikum warahmatullahi wabarakatuh, sir. I'm Najmi Elsoraya, and I want present my mind mapping from my critical review. The title of critical review is Green Synthesis, Characterization, and Biological Activities of Zinc Oxide Nanoparticle by using plant extract. Before I explain more about my critical review, first I want to explain about the definition about green synthesis. Especially for me, green synthesis is the more new word that I hear. Usually I only hear synthesis in chemistry, and now I hear green synthesis. After I read some journal, I found that the green synthesis mean is a clean method utilized for synthesis of nanomaterial by using by eliminating or decreasing hazardous material used during the fabrication process. This is the definition of green synthesis. So, many researchers did the experiment about the green synthesis, especially for nanoparticle. What the reason I will present. Before that, I wanna explain about the aims. Why the researcher do the green synthesis? The goal or the aims of green synthesis is to protect the environment, not only by cleaning up, but also by inventing new chemical process that doesn't defile. This is the aim of green synthesis. Okay. I will explain about, first I wanna explain about my sources. My source. Yes, my source from the critical to make the critical journal is many sources journal that have English word or international journal. I 55 journal to make one critical review. This is the journal. This is the one of the journal, Green Mediated Synthesis and Characterization of ZnO nanoparticle using euphorbia jatropal latex as reducing agent. This is the name of the journal, but now I can't explain one by one because this is so many sources that I put here. So we can go to ZnO nanoparticle, the part of ZnO nanoparticle. Yes, this is ZnO nanoparticle. Before we know about ZnO nanoparticle, a green synthesis of ZnO nanoparticle, we must know about what is ZnO nanoparticle. Okay, ZnO nanoparticle is the part of metal oxide nanoparticle. Metal oxide nanoparticle is in chemistry, we learn this in the inorganic chemistry. We can learn the metal oxide nanoparticles. And the metal oxide nanoparticle is the part of nanomaterials. Yes, nanomaterial. So in our universe, there are so many nanomaterials that can synthesis by the researcher or chemist or scientists. And from the journal, I found that the nanomaterial, the properties of nanomaterial depend on the size, distribution, morphology, and dopant concentration. Usually, the size of nanomaterial from 1 until 100 nanometer. And I found that the information and the nanomaterial have higher surface to volume ratio. That's why nanomaterial is high reactivity. And nanomaterial have a superior physicochemical and biological properties. So the ZnO nanoparticle is the part of the nanomaterial, and ZnO nanoparticle properties of a general nanomaterial. Okay. Okay, ZnO nanoparticle is can show the higher quantum efficiency. Why? Why ZnO nanoparticle can show that? This is the reason. It absorbs more quantum of light in the UV region. So this particle, this material can show the higher quantum efficiency. So in 21st century, the quantum is the more interesting. It's the more interesting in 21st century. So we must know that the quantum efficient, the quantum, chemical quantum. So, before I read the article, I wonder myself, why must the ZnO nanoparticle? What answer we can see in the properties of ZnO nanoparticle. This is the properties: environmentally friendly, non-toxic, corrosion-resistant, excitation binding energy of 60 milli electrovolt, band gap about 3.37 electron volt, high piezoelectric, antimicrobial activity, strong absorption ability, anti-inflammatory, having longer life, antioxidant, protective effect against UV rays, nearly insoluble in water, non-toxicity, and biocompatibility. So this is the properties of ZnO nanoparticle, and it make the ZnO nanoparticle is interesting to do the research. Researcher do the research about this material, and we can see in the morphology of the particle from the shape of crystal. Researcher found the most shape of crystal is 3 shape. First is hexagonal wordite with the band gap energy about 3.4 electron volt. Can see in the visible region and UV region, and then cubic zinc blend, cubic rock salt, and most of the ZnO nanoparticle in the form of hexagonal wordite. And the form is the white powder. This is the form. So after I read the journal, I found that the answer why ZnO nanoparticle is very interesting, very interesting, and also because the unique properties ZnO nanoparticle also have many applications in our daily life. So we can see the application in our daily life, ZnO application. First, we can see this, the photoelectric semiconductor. So ZnO nanoparticle have a properties that can biological labeling, ceramic and rubber processing, and additive in numerous material like plastic, ceramic, glass, cement, rubber, lubricants, paints, foods. Food is the source of ZN nutrient, pigment, adhesive, battery, ferrites, and fire retardants. This is the application. And then semiconducting material. Why ZnO nanoparticle can use in semiconducting material? It's because they absorb the photon of energy in the range of UV regions, generally. And then degradation of atmospheric pollutants, biomedical, yeah. ZnO nanoparticle have have many advantage application in our daily life. Biomedical like anti-angiogenesis, anti-platelet agent, anti-inflammatory, dental materials, cosmetic, drug, gene delivery, sunscreening, wood health agent. And food industrial, yes, food industrial also apply the ZnO nanoparticles in the food packaging, various materials. And also for the chemistry, it's catalyzed ZnO nanoparticle that helpful in reduction or elimination of toxic hazardous chemical from the environment like arsenic and sulfur. And then photocatalyze, this is the reason why ZnO nanoparticle can apply in the photocatalyze. First is the simple and cheap fabrication material, high photocatalytic activity, non-toxicity, and the high photosensitivity and stability. These are the application of ZnO nanoparticle in our daily life. So we can see how to make the ZnO nanoparticle by the scientists. And from we go to the green synthesis, we can see there are no green synthesis is not only way to synthesize the ZnO nanoparticle. The other method that used in synthesis ZnO nanoparticle is physical method. This is the example of physical method: evaporation, pulse laser deposition, sputtering, metal organic chemical vapor deposition, molecular beam, vapor phase transfer method, microwave technique, aerosol process, non-sputtering. So there are so many methods in the physical method. And chemical method like precipitation, hydrolysis, pyrolysis, salt gel, hydrothermal, sulfothermal, spray pyrolysis, electrodeposition process, mechanochemical method, sonochemical, polyol method, ultrasonic condition. So why we use the green synthesis? No, bukan we. But why the researcher use green synthesis from physical and chemical synthesis. This is the answer. For the physical method, the limitation is expensive and require high vacuum and energy consuming reagents, long and tedious process generating waste that is not friendly to the environment. Okay, now we can see in the synthesis of ZnO nanoparticle. First, we can go to the some important, yeah. Yes, biosynthesis of metal nanoparticle. This is the three important point that we must considering from the green sign before we synthesis by using the green synthesis method. First is selection of solvent medium, selection of stabilizing reagent, selection of reducing agent. These are the most important. And for method, first we can go to the phytochemical screening test. Phytochemical screening test is the test that used to determine the active compound in some extract, and in this case we extract. Okay, there are so many phytochemical screening because the plant extract the plant extract contains saponin, alkaloid, protein, flavonoid, phenol, carbohydrate, terpenoid, steroid, and glycoside, tannin. This is the test for we can test this plant contain alkaloid or not by using Maillard test. This is the positive result if the plant consists alkaloid. We can do the Maillard test, and this is the result. Creamy precipitate if the plant contains alkaloid. So these are so many phytochemical tests. And then preparation. Yes, we must to prepare the something that related with our green synthesis of ZnO preparation of ZnO3. This is the one of the precursor of zinc atom. And then preparation of the plant. Yes, we must prepare. Now this is the precursor: zinc nitrate hexahydrate, zinc acetate, zinc sulfate, and also zinc chloride. This is the precursor from the green synthesis ZnO nanoparticle. And before that, we can do the determination of biological activity in this review. In this review, I only found the 6 biological activity. First is antibacterial activity, antioxidant activity, anti-cancer, antifungal, antibiofilm, and anti-diabetic activity from the ZnO nanoparticle. Okay, and this is the advantage. Why the researcher do the green synthesis? The material is easy to get, simple know the process is good or not. Okay. Okay, this is the plant extract. Plant extract example is so many example that I can explain one by one. And the function of plant extract is stabilizer, reductor, and capping agent. This is the stabilizer. Activation pass, grow pass, termination pass. Okay, after we synthesis the ZnO nanoparticle by using green synthesis method, we can do the characterization to determine the compound in our molecule or our plant extract. First is FTIR. This is the common group, XRD to analyze the crystallinitas, SAM-ADX to show the surface of morphology, XRF to know the composition of precursor, HRSAM to providing information for topographical, morphological, and composition, ADAX to study the elemental composition of the sample, and AFM analysis to insight about the topography, TIM to characterize size and shape, AAS method to confirm the purity of the sample fabricated by ADX, FASAM to observe the morphology of ZnO nanoparticle, DLS to observe the size distribution profile, photoluminescence scan is to show the surface state, XPS to confirm the composition of the substance, and the last one is UV phase. Usually measured at 376 nanometer. This is the function to examine the optical properties of nano-sized particle and perform to further confirm the formation of Thank you very much.